everyone. In this session, we are going to discuss about the algorithm for backpropagation neural network. In the last session, we have discussed how the architecture of backpropagation network will look like and what is the exact process. So this is a continuation of the previous session. Okay. So here, backpropagation network, it is actually divided into three phases. So first one is feed forward of input. We take an input neuron, input pattern, input factor like future whatever it is. We send that to the input layer, to the hidden layer, and hidden layer to the output layer. We calculate the output value, and then back propagation of error. We calculate the error function between the final layer to the hidden layer, and then hidden layer to the input layer, and then the weight adjustment. Okay, so the algorithm actually will goes like this. So first step is feed forward of input. So what we do, we take an input and output pattern. So you will have this input vector and it has its corresponding output vector. We call it as an SI and TI. S is your input and T is your target. So first we take this input neuron vector, whatever is the value, we feed it to the input layer. So all your XI take the first pattern of SI. Okay, so first input pattern and it is then fed into the input layer. And then we broadcast the signal to the next hidden layer. So that means we are going to pass the input of X to the hidden layer. And how the values of the hidden layer is calculated. You know the neural network connection, how it works, like when it is connected like this. And if I am sending some inputs over here, you will have a weight values here. Okay, so here it gets the input from this X value multiplied by this weight vector, this X value multiplied by this weight vector, and it is added together. Okay, so this is how your input layer or the hidden layer output is calculated. See, the function is given over here, Z in Z. So it has a bias value. So when I take this first neuron value, output value is calculated as this vector, that is bias value of 0, 1 plus it takes the value of x1 multiplied by this weight vector of b1, 1. Okay, so this receives the input from first neuron with this weight and it is added together, and it receives input from this neuron to this and this neuron to this. So it is your Z in J function. This is for your bias value weight vector followed by summation of all your input neuron to that corresponding Z neuron. When I take Z1 receives signal from all your n number of input neuron from X1, Xi, Xn. Okay, so this is then multiplied, the input and the weight vector is multiplied together and it is added together. So this is how your weight vector is calculated. Okay, so this is how the input is passed from the input layer to that of a hidden layer. The values are calculated. So that is not your exact output. It is Z in J. Okay, so that is how the input is actually received. But the output of it is based on the activation function. Okay, as we discussed in your perceptron network, for each and every input, we have a target output to be calculated and that has to be normalized, like it is usually not the same output that is needed. One example I can give it is like the value that we are going to calculate here will be of numerical data. Okay, it might be it is always a value in a numerical, it is a numerical value, and if the target needed is I want to predict whether a patient is having a diabetics or not, the output is yes or no. Okay, so this has to be calculated, it has to be converted. So that is how, based on the expectation of the output, the target value, we use an activation function. If it is a binary activation function, we can just convert the given output, the exact output that we receive, to a binary output of 0 or 1. Okay, we use a threshold. If it is beyond this threshold, I take it as 1. If it is less than this threshold, we are going to take it as 1. So that is the next value. So first we calculate the input that is received over here, that is called Z in Z. Whatever input it takes from the neuron, and from this we calculate ZZ. Okay, so ZZ will be your output after applying the activation function of Z in J. Once it is calculated and then this ZZ is passed to the output neuron. Again the same calculation is happening here. We calculate y in j. So y in k is, it takes one neuron from the bias value and followed by it takes the output of each other. Like when I take y1, it receives the input from all your hidden layer neuron. Okay, so altogether the value of zz followed by the weight vector, it is combined together and it is passed to the output neuron. So that is how it works. Okay, so summation of all your zz for the corresponding k neuron, you are going to combine it together and the value of y1 is calculated. Okay, so once this y in k is calculated, again you have to apply the activation function based on either it is in binary or bipolar activation function, and we get a target output of y here. So one input is taken and that is calculated to the output of y. So x is your input, y is your output that is calculated, and now the next step is we are going to find the output. See here, this is a feed forward of input that we have discussed. The input neuron receives the input. So the xi is your input pattern that is given to xa, and we broadcast the signal to the hidden layer. So this is then passed to the hidden layer and activation of hidden layer is calculated. So this value of z in j is calculated. So this zz signal is then sent to the output neuron. So once after calculating this zz, it is sent to the output neuron and then the activation of that is sent back. The output layer calculates its yk. The final output is calculated. So now after calculating, so this is the first stuff, taken an input pattern, pass it into the input layer, hidden layer and the output layer, one output is received. Now you are going to have, it is a supervised pattern, right? So you have a target supervised output for it. So for each and every input pattern, you have an exact target that has to be achieved. Okay, so now you got that output value of y, compare it with the target that is needed. So that is for each output units, compute its error function. You are going to check whether this target and the yk that we have calculated is same. If it is not same, you are going to find the error function. And how you are going to calculate this error function? It is del k based on your generalized delta rule. We are going to use the formula of generalized delta rule. Find the error function between the output and the hidden layer first. Between the output layer and the hidden layer first. Then we go for weight updation. Then from the hidden layer, either you can just skip the weight updation part later or you can directly do it in between two. Okay. So now error function actually flows from output to input. That is very important. So output to hidden, output error function is calculated, weight is updated, and from hidden to input again we are going to proceed with it. Okay. So this is for the first one pattern. So we take one input pattern, pass it, get the target. And if the target doesn't matches, change the weight pattern and then you have to proceed. You have to check for the stopping criteria. If the stopping criteria is done, stop it. If not, you can again start from this first step on taking the next input pattern. Okay, so this is how a back propagation neural network actually works. Now you should know what is this, how to calculate this y in k and z in k and how to apply the activation function. So next video I'll just show you the formulas for this z in z calculation and the activation function for it. For different activation function, we have a different patterns to be followed. It is just formula. I'm not going to explain this generalized delta rule. I'll just give you the formulas for all and one example I'll show you how it is exactly working. Thank you.